I have officially named this device the Tubal-Crane at the suggestion of several viewers. Another good name was the cane crane. Howdy again, it's Mr. Pete, and this is tips number 729, improvements of the Tubal-Crane. This is the third in a series. There also will be a fourth where I attempt to mount this on the lathe to remove chucks, so be sure and watch for that too. Go back and watch the first two if you have not seen them. They were semi-popular according to what I normally get in the way of views. There were hundreds of comments, some of them were even favorable, and a lot of good suggestions. So in this video, which will be a terribly long one, I'm going to modify and improve this. This, after all, was merely a prototype, and you learn so much with a prototype, and you people are benefiting by that. And I do understand that a lot of you old geezers like me are probably going to build one, something like this, for your own purposes and to save your back. So let's get started as I beat this horse to death. I do indeed recommend that you watch these two videos if you have not already seen them, or watch them again for the pure pleasure of it, or this particular video may not make a whole lot of sense to you. Sooner or later there will be a video where I adapt the Tubal-Crane to the lathe for lifting off heavy chucks, so watch for that. In this video I intend to address many of the comments, both critical and good ones too. Many people did not like this. They said this is for horses, or one man said it's to lead a bull. I don't know, but it's quite heavy duty. The reason I used it is that it has a swivel, and it's kind of hard to find these hooks with a swivel other than very large items. Some suggested this, but this reminds me too much of somebody that climbs mountains, so they must be pretty strong, but to me, I don't like the looks of it. I wanted something that looked like a crane, like some of these examples I have here. I think you know the names of these hooks. This is called a grab hook, and the purpose of it is to grab a link, and you have to have the correct size for the correct size chain. They tend to allow the chain to hang over rather than directly under, so that's what I don't like about that. This is called a slip hook. This is really what I like, other than this one is relatively large, but that is a nice one. This one, although it looks like this, actually is from a safety belt that men would use when they're working on steeples or trees or something like that. So we know that would be incredibly strong, but again, no swivel, but I like the large loop, don't you? I guess I forgot to show you this, but this is really the size of grab hook that I want, but again, no swivel. I did have one with a swivel, but this came off of a link belt crane. This thing's huge. I'm surprised it doesn't have a ball attached to it, but I do like it very much, but this is the proportion that I was looking for. This is a 10-inch rotary table. I had Jordan lift it up here for me yesterday because it was under a bench, very awkward to get at. 10-inch weighs 75 pounds. When you get into a 12-inch or a 14-inch, you darn near need a forklift or a die cart or something like that to handle them. They are just tremendously heavy. I was going to do this anyway, but I don't know how many people said, "Well, you fool, why don't you open up the back side here so you can pump from either side?" Well, I'm going to do that right now, as a matter of fact. I cannot think of any tool that I own, a power tool, that I dislike using as much as one of these nightmares. Do you have a little beauty like this in your home? Do I seem crabby today? I don't mean to be. I wish I was more even-tempered like A-Bomb. But Some people were worried about this slipping out of the vise. Can you say 10 tons of pressure? I'm quite angry at myself for cutting this off, because originally the boom was this long and I thought, well, this is plenty long. Again, a prototype, you got to learn all this stuff. So that, remember, my table's only 32 inch here. If I move the vise down, I have just the right amount of reach, and this would have been way too long. But I do not have enough reach when I swing the boom over to the cart. So that's where I need the extra length. Some suggested welding on, but I don't like the idea of welding tubing, especially thin wall tubing like that. That's a bad idea. I have no intentions of doing that. I have several solutions. So I decided to make a boom extension. This is 1/2 inch thick and indeterminate width, but it looks like I sawed that many years ago. There's bluing on there, so I don't know what the occasion was, but it was setting in the corner of my wet basement. Remember, the house was built by Laurel and Hardy, so look at the corrosion from setting in the corner. So I started from the other end, and there is the boom extension. That was all one piece. Get in the frame, get in the frame. I drilled a series of holes. The large hole on the end was already there. I did have to open it up a bit, but how fortuitous was that? So the whole idea here is that the boom extension will go right into the tube, and I was very lucky that the inside of this tube seemed to be a nominal size. Sometimes you're going to run into wells on the inside of tubing that make it very difficult. So I can move this into one of 5 or 6 holes, whatever I got there, and pin it, and that gives me that extra length that I want. So I think that's going to be pretty useful. You know, I run into a lot of frustrations. For instance, this is the hook that I wanted to use, but the clevis here will not fit through this eye. So at least for now, I'm using this outrageously large link belt Lorraine. Maybe it's from a Lorraine. But look at the extra reach that gives me. In fact, so much reach that I have to push the vise way down in order to use it. Again, I'm not scolding you, but probably the most important thing in the first 2 parts of this video is this knob. 2 people mentioned it, but it's just such an improvement for a jack to have a knob on there instead of that nightmare little, sometimes it's a prong like a T-shaped thing, but it's cheaper to make it flat, so now they're using, you know, this type of deal. Don't like it at all. Take that for what it's worth. Maybe it's worth nothing. Let's see how that works. And now, of course, I'm able to pump from either side, but it's awkward to pump up. That's the disadvantage of the handle going in from this side as opposed to that. As a matter of fact, it's very clumsy. Now, and I am accused constantly of being unsafe. Honestly, I think I'm the safest operator on all of YouTube. Boy, that'll get a rise out of people, won't it? But look at the reach that I have right now. Gotta have that swivel. Wow, that extra 4 inches really puts the vise just where I want it when I bring the cart into place. Let's do that. How's that? Pretty darn good, actually, isn't it? Now, I've had some suggestions where people said, why are you mounted here? Why don't you mount it someplace back here, or have a bracket, or even on the end of the Bridgeport boom? But then you'd have to turn the turret way around. It'd be so difficult to use, in fact you never would use it. But I received over 100 comments, and I don't know why I torment myself with reading the comments, although most of them are good. 100 people said, why don't you mount this on the cart? Good idea. Let's do that. Just for laughs, I'm weighing the cart. £26 of plastic. And how stable is the Rubbermaid cart? Well, you know, the thing's 18 inches wide, but the stance between the wheels is 14 inches. No stability at all. Major outriggers needed. Okay, now you know this isn't going to work. I just did this to placate the masses and for the fun of it. And I wasted a half hour out of my life putting this big beam here. And these are 1/2 inch lag bolts that are, shoot, to 3 inches long. Now this is my lightest vise. That is, it weighs, what did I say, 40 pounds. So let's see how the plastic cart holds up to that. I gotta back the camera up and I'll show you that again. Yes, quite the abject failure, as predicted. Now why didn't that work? Perhaps I should have used my metal shop cart. That came from the freight store in the bay, and it probably weighs 12 pounds and is made of foil. Absolutely worthless. In order to use a cart, the cart would have to weigh 500 pounds and have outriggers. Some heavy-duty type cart that they might have in a welding shop someplace, or in heavy industry, that would work very well, but certainly not on any of these silly little Rubbermaid or horror freight carts. And yes, it looks like the wreck of the Hesperus. I hope I didn't insult anyone with that tirade of mine. Let's cover this now. Many people said that this needs to be much wider, that is, let's say double. And out here, not near the end, remember I got a short table here, that's why I had it out here. I got a reason for everything, pretty much. And that you're going to break the T-slots out on this machine. No way. No possible way. I'm going to talk more about that in a minute. So I stand by the fact that this is just perfect place to put it on this machine. And of course somebody said, well, why aren't you using T-bolts instead of T-nuts? Because I can position these in place, and remember, I want everything to be fast in just a matter of seconds. I've got these on and tightened, so this is just really perfect for me. Do it any way you want, of course. Then of course I was considered harshly by just having stitch welds all the way around. That's going to break out, which I don't believe it is with the amount of weight that I'm applying and the extra force and moment of the arm and all of that good physics stuff and math stuff. That's plenty strong. Some suggested using a flange, a machined flange. That's originally what I was going to do, because it's very easy to square up something using a flange, but you couldn't buy a commercial pipe flange that is going to work. You'd have to make something up on your lathe, and a slightly thicker or bigger plate here, and I was going to even go with a slightly thinner one. I had a thicker one I started to use, but remember, weight is what it's all about as far as I'm concerned. I don't want this thing to weigh anything. Remember, it's only 12 pounds. Alright, let's talk about breaking out the T-slots real quickly. I've covered that a lot of times, but one more shot. I'm back at my rotary table here on the bench, and you can see that Bubba broke out large pieces here of the castings. Now that is done not just by over tightening the nut, it is done by using the wrong kind of nut down here, T-nut, and the bolt coming through and acting as a jack, breaking that out. That's how 90% of them are broken up. And of course Bubba has no idea how strong he is in the arm and how weak he is in the mind. One other thing, again, you're going to have a heck of a problem finding tubing that fits into one another. A good source of that is from the curb, where you will find exercise machinery and all kinds of stuff like that is discarded because people hate it. And it tends to be a little thinner than this. Matter of fact, a lot thinner. It's all about making it cheap and in price and cheap to ship. But a lot of that tubing telescopes into one another, so it's good. Somebody said, why don't you use aluminum? Well, then you can't weld it. Where are you going to find aluminum other than in maybe one of those hospital lifts? And if you're just using your own aluminum around the shop, you're going to need thick wall or, struts out of a DC-3 landing gear. So stick to steel. By the way, originally I fully intended to weld gussets in, probably about 4 of them, but I got lazy. Now someone suggested when I was talking about thrust bearings that what you really need to do here is on the top weld a little plate. I'm just going to use this washer to illustrate it with a little hole in it. Weld it on there so it's permanent. Place a ball in there. I don't know what size ball, and then I already have a hole right here, and that would greatly reduce the friction as you're swinging the boom. Just a suggestion, I don't intend to do that. I think you know that I had limited boom movement. Now I added the 5-inch extension on there. What was the original? I think 9 inches. But now I have about 16 inches of travel. If I can push that down, overcome the oil. There. That's as far down as it goes, but I measured from this and had that amount, what did I just say, 16 inches, so it greatly increased the travel. Here's a little irrelevancy. Have you ever been on a committee, whether it be at school or at work or community or church, wherever it is? You're going to find that if you got 3 or 4 or even 10 people, you cannot come to an agreement or a conclusion. It's just impossible. The more people you have, the harder it gets. If you got 3 people in a car, you can't decide. You're going to argue about where you go to eat. And it gets to be pretty trivial too. But anyway, why am I saying that irrelevant thing? Because essentially what I'm doing now here is engineering and designing by committee, trying to incorporate many of the brilliant ideas shown in the comments. Be sure and read the comments. There are hundreds of them, and you will find some of them quite entertaining. I do read them all. I can't answer all of them. I was brutally criticized for the location of this point, and I knew that it was a little far out, but it doesn't look so far out now that I have the boom extension on there, does it? But people said, well, get it much closer to the post, and originally I was going to put it more about into here. Remember, this is a prototype. So several people said, well, it's still crazy. You need to have this exactly vertical, which I don't understand that at all. Some people said put it on the back. The boom should be longer here, and this could be on the back. I suppose that could work, but this would have to be totally re-engineered here. So what I haven't told you yet is I'm going to build a new boom here presently, most of it off camera, and it's going to be longer. Matter of fact, I think I'll make it this long. I have another piece of the tubing. I had to go see a man about that. And I will move this point more into this range. I'm not sure. I might be able to use this. This is a piece of tubing that I cut off, larger tubing. Possibly I can use that, someplace in there. This would also be good. Drill a hole in there, clamp it tight, and try it in different positions. Again, you guys that are good with CAD can do that. I'm incapable and ignorant of that. Do you recall in part 1 of the original video on this crane that I wanted to actually put a winch on here. It would be a fixed boom, forget about the jack, and put a winch on here. And I did all kinds of research on that. I was going to use a boat winch, a boat trailer winch, but you know, they aren't good for lifting, they're good for pulling. They have a single pawl on them. They can get away from you, although someone told me you can get winches with a double pawl. I was unaware of that, but I was most pleased that I got a comment from someone saying, why don't you use the tiny winch that they use in a pickup truck to store and lower the tire, the spare tire. I think most of you know what that is. And I'm going to put a picture on here in a minute. On eBay, they're $30 or $40. Do not go to the junkyard. Every one is ruined within 3 to 6 months by the weather. Did you ever try to lower a tire on Route 80 in the middle of the night during the rain or the snow and it's stuck? The only way to get them off is to cut the cable. It's the world's biggest nightmare, but they are quite compact and cheap, and wouldn't that work just great to have that mounted up here? Thank you for that idea, but of course it's too late for me. This is a picture of a spare tire hoist, most often used on pickup trucks. It would be perfect for this application. They're about 30 bucks. Do not go to the junkyard and try to purchase one of these. Everyone is ruined by the weather within 6 months and is inoperable. Also, someone suggested using a pneumatic cylinder here, which I don't think is a good idea at all. First of all, it's going to be too heavy, then you got to bring an air hose over, and I don't know how quickly they react or if there's a valve where you can operate them slowly, but that's just not something that it would interest me, but it might be a possibility for other people out there. Now, my daughter just recently scrapped 2 cars, and she called me over and said, anything you want out of these cars before the junk man comes. I took both jacks out, thinking I might be able to incorporate those screws some way in here, but I didn't. But oh, how I lament the fact that I did not take that little winch that we're talking about out of her, oh, I think it was a Dodge Caravan or something like that. I could have had that at least to talk about if it wasn't ruined, which it probably was. Is anyone actually still watching? Because it's been about 22 minutes of me gabbing. I'm fully aware of that, but there were just so many things that I wanted to talk about as far as the design and the engineering. But what I'm going to do now is to take this piece of tubing, and that's 30 inches long, no rust on it, although it came from the same source, and I'm going to replace this. Now, how long am I going to make it? 30 inches, of course, would be preposterously long, so I'm not going to use the full length. This is, according to my meter stick, about 20 inches long, including the boom extension, so I'm going to cut it off at 20 inches. I'm committed to that, and this will be scrap, although I really like this boom extension here and the fact that I have the possibility of changing the length. This really is good and might be better than the new one that I'm going to make. And I will change the location of this pivot point arbitrarily 2 inches in from the other one. Or should I say 500 millimeters. I just had a brilliant idea for my hook. Here's a chain binder, 1/4 inch, which probably holds 10 tons. Well, I'm going to sacrifice this because I got 10 of them. I'm going to remove the pin here, and that, I'm going to call this, it's almost like a clevis. No, it's nothing like a clevis, but anyway, that can go up and straddle. Or this end, take the pin out. Well, I'll do that and I'll be back with this piece and decide which one I'm going to use. And I just got back from the garage and I cut this off to the correct length. So of course the hooks will be attached to this. I would of course paint these red, but on this piece what I would probably do is cut it off where you see the white arc there, because the idea is to put it on like this, but it's a little bit long, so if I cut it off there, drilled a new hole where X marks the spot, and mounted it something like that, that would shorten it up, and that would make it quite serviceable. I know the safety Nazis will kill me for not having that safety tab on there, whatever that's called. And the other choice is, and I think it's a 50-50 proposition, is to put this on there. There is a slot. I would have to widen it a little bit, and that could go in there, or more than likely this too would be cut off and shortened. But either one of these I think is a great idea because there's a swivel on there. And since they're a grab hook, I can put an extension on there easily of 1/4 inch chain with another hook. What do you think? It's a half hour later, and this is the modification that I made. And the piece that I'm going to use, and it'll go in like this. How about that? Now, looking down at the other end, as I told you, I want to move this pivot point down about 2 inches. I have already determined that this piece will not work. But pulling that pin out, you can see that at some point here, that's as far up as it's going to go before it strikes with an interference down at the bottom, which is fine. I don't want it to be perfectly vertical, although by popular demand several people do. So I'm going to move it down. I'll measure here, but it's right about 2 inches is what it is. Okay, there it is with the long boom. Now all that needs to be done yet is a couple of small welds right in there to keep this bracket from turning, and some paint, and the revised edition, final edition for that matter, is finished. Took a little longer than I thought. Okay, I got a couple small welds right here that'll hold that bracket into place. It's still too hot to touch. It's pretty much finished except for paint. So I'll clean it up a little bit, put a coat of primer on tonight yet, and tomorrow morning the red, if I can get that can of paint to work, and then the following day I will demonstrate and we'll be done with part 3 of this project. See you tomorrow. Pretty corny. Well, actually it's 2 days later. I had to wait for the doggone paint to dry. And I'm going to sum it all up here in just a few minutes, but as you can see, I put the extension here on this boom. This is the short boom. I may never use it. This hook will be replaced. I don't like it any better than you do, but really I want to talk about the new boom on the Tubal-Crane. This is welded now and it's ready to install, but let's talk a little bit about the hook first. So this is what I was going to use, and you know, that's what you get for painting in the dark. Missed half of it. Alright, that's going to go on like that. But this is a grab hook. Now there's nothing wrong with a grab hook other than there's no safety latch on it. This is the one that I would really like to use. But before I change that, I want to show you with the grab hook the convenience that I would have by adding a length of chain with another hook on it. That would allow me to reach all the way to the floor, which I probably never would use, but I'm just saying. And I have a question for you before we move on here. Is this repaired link here up to OSHA standards? Now I can always add a few links of chain in there if I need the extra length, but for now this is the way I'm going to assemble it. So let's go on over and put it on. Alright, let's put this thing together for the final time. By the way, I do have one of those Harbor Freight hydraulic carts out in the garage. They're a lot heavier than this plastic Rubbermaid thing, but they do not go all of that high and still not heavy enough to mount the crane on it. So this is what it looks like as a finished crane. And the worst idea here in this whole project was putting the handle over on this side, because it is so unnatural to go up, and you just lose all of your ability to create a lot of pressure on it. So it really has to be done from this side. What do you think? Looks pretty good, doesn't it? I know you will think I'm a champion of the obvious, but never put your hands underneath the load that you are lifting. If it's a real large load on an overhead crane, you never walk under it. You don't take any chances of a failure of a hoist, because it can happen. Alright, enough on that little rant. Let's lift this rather heavy. This is a 10-inch rotary table, and it weighs 75 pounds. Now I'm only lifting it here, what, 6 inches or something, but it works just great. Now I got the extra reach that I need with the new boom. And it goes down farther since I have changed the position of the fulcrum right here. Now this rotary table and most other ones have a crank on it that extends below this surface here. So generally you need some wooden blocks underneath it, and the handle has to hang out over the Bridgeport table. And I will swing it over. And that's why you need a swivel. Now notice that the extended boom here places the rotary table far at the end. But that's not really a problem, because what I do now, and most of you probably have a longer table than what I have. This is the short table, 32 inches what I believe it is. Then your vise or your whatever your device is, a rotary table or index head, can be slid around very easily once it's on the table, and then clamped down in position. Again, notice that I have the entire crank assembly hanging over here, because it extends down below the level of the machine table. And yes, it is much harder to find the center of gravity on a rotary table. It is not in the center because we got all this excess weight over here. So by moving your eye hook one way or the other, and it has to be by experimentation, and rotating the table a little bit, you can find pretty much the center of gravity. I wasn't exactly on it, but it worked pretty good. This is really something I can no longer lift. It's just too heavy. But just got to lift it up 1 inch, Now this is probably the heaviest thing I will ever lift with this crane, and it swings very freely. I just do not see any need at all for a thrust bearing here or any other place, or even putting any grease on it. Well, I hope you enjoyed this series of videos up to this point on the building of the Tubal-Crane, but wait, there's more. There will be a part 4. Also, there's a lot of still pictures at the end of this very long video. I know some people seem to like those. Watch the video 3 times. Here's what I will do in part 4. Okay, what will part 4 consist of? Well, I'm over here at the closing lathe, and these chucks are about 40 pounds. I do have a little problem wrestling them, and I'm not getting any younger, but some way or another I plan to adapt the Tubal-Crane onto this machine. I don't know if it'll be mounted directly onto the machine or even a post on the floor or whatever, and the whole idea here is to be able to lift the chuck off and swing it around onto a storage table or whatever I decide on. And I do believe now that the boom is way too long for this job, so I'll probably switch back to the shorter boom when I do that. But enough about that, and it's already a work in progress, as you can see by the device I've made here to lift the chuck. So be sure and watch that video. Hope you enjoyed this. It's Mr. Pete saying so long for now. Where's that puppy, Sophia? Come here, Finn. What do you smell? Come here, buddy. Don't get a chip in your paw. Don't get a chip in your paw.